Imagine your development team just cut sprint time in half. Features are shipping faster, the backlog is shrinking, and leadership is happy. Now ask yourself one question. Did anyone check whether that code is secure? Because there's a growing gap between working code and secure code, and AI is making that gap harder to see. You may have heard the phrase vibe coding. It's not a formal industry standard or a term defined by NIST or OWASP. It's a popular informal description of AI-assisted software development using tools like GitHub, Copilot, or OpenAI's Codex, focusing on refactoring to streamline the code base and accelerate delivery pipelines. These tools are trained on large volumes of public code and can produce functional results in seconds. The core question for cybersecurity professionals isn't whether these tools are useful, because they clearly are. The question is whether the code they generate is secure by default, and the research suggests not always. Here's the fundamental problem. AI coding tools are optimized to produce functional code. They will generate something that compiles, passes basic tests, and does what the prompt requests. What they are not optimized to ensure is that the code is free of security vulnerabilities. That distinction between working code and secure code is the most important concept in this video. A function that processes user input might run perfectly in testing and still be wide open to injection attacks in production. Let's look at what the research tells us and be precise about it. In one study of GitHub Copilot across 89 security-relevant scenarios, researchers found that approximately 40% of the generated programs were vulnerable. That does not mean all AI-generated code is insecure, but it does mean that, in security-sensitive contexts, a substantial portion of AI output requires careful human review before it reaches production. The reason traces back to training data. Models like Codex are trained on public repositories, and those repositories contain bugs, legacy patterns, and known vulnerabilities alongside good code. The model learns patterns from all of it. To build an accurate picture of risk, it helps to separate three distinct layers. First, AI-generated code risks. These are the vulnerabilities baked into the code itself, from insecure patterns to problematic dependencies. Second, LLM application risks. These are issues that emerge from how AI models are used in applications, not just the code they produce. Third, enterprise governance risks. These are the organizational accountability gaps that allow AI-generated code to move from developer to production without adequate oversight. Your risk strategy needs to address all three. OWASP's Top 10 for LLM applications identifies several risks directly relevant to AI-assisted development. Prompt injection, LLM-01, is the primary attack vector for large language model systems. Insecure output handling, LLM-02, occurs when AI-generated outputs pass into downstream systems without validation, potentially enabling remote code execution. Supply chain vulnerabilities, LLM-05, reminds us that AI tools introduce dependencies that can themselves be compromised. And over-reliance, LLM-09, may be the most significant cultural risk. When developers stop critically reviewing AI-generated code and accept suggestions without scrutiny, they become the last security control, and they've effectively switched it off. NIST's AI risk management framework is clear. AI risk governance is not a technical problem alone. It is an organizational one. The framework's four core functions are govern, map, measure, and manage. And these apply to any enterprise that has adopted AI tools in its development pipeline. Senior leadership must take accountability for decisions about AI deployment. Organizations need to maintain an inventory of what AI tools are in use, in which workflow, and under what review conditions. You cannot manage risk you haven't mapped. Traditional secure software development lifecycle practices were built for a world where humans write every line of code. That world has changed. NIST calls for continuous test, evaluation, verification, and validation, the acronym TEVV, integrated across the entire AI lifecycle, not just at the end. The best practice reference in the research is role separation. The teams using AI tools should not be the same teams validating AI output. OWASP, SAM, and NIST Secure Software Development Framework are the primary frameworks enterprises should be aligning to now. Here is the core principle. AI tools can help write code, but humans and organizations still own the security decisions. NIST's AI RMF is explicit. Human oversight roles must be clearly defined to ensure AI outcomes remain consistent with the intended use. Code review is not a bureaucratic checkbox. It is the primary security control in an AI-assisted development environment. If no human is critically reviewing AI-generated code before it reaches production, you haven't eliminated a step. You've eliminated your last line of defense. AI coding tools are not inherently dangerous, and they are not going away. When you use them responsibly, they offer real productivity gains. But speed without oversight is a risk multiplier. If your organization is using AI-assisted development today, ask 5 questions. 1. Do we know which tools are in use? 2. Do we have a review process for AI-generated code? 3. Are our SSDLC controls updated? 4. Does leadership own this risk category? And finally, 5. Can your developers articulate the difference between code that works and code that is secure? If this video helped clarify the security landscape around AI-assisted development, subscribe because we publish no hype, research-backed cybersecurity education every week. Please leave your questions in the comments below, and we'll see you in the next video.